Okay, so I just want to walk you guys through the process of sketching a ray diagram for flat mirrors in this case. You follow the same exact rules for curved mirrors, but I'm just going to show the example for flat since that's what we've talked about so far in your homework. Okay, so I've got the rules, and you'll notice I'm going to kind of bring the rules back and forth in and out of the picture, but you'll notice that I kind of have each step in a different color. Okay, and so the drawing that I'm going to use is going to use the same color as the step that it corresponds to. Okay, so the first step is just to sketch your object and the mirror. In this case, it's a flat mirror. Okay, and you should be able to, for flat mirrors, already decide what distance your image should appear at, and we're going to go ahead and label that distance point and see if with my sketch it kind of turns out. So I'm going to just do that in black so you see. And for my example, I'm going to show my mirror here as just a straight line. Okay, so this is my mirror. Okay, and let's say that, let's do centimeters. I have an object that is 10 centimeters away. Okay, and that object, oops, I keep turning my paper. Let's make the object 2 centimeters tall. Okay, so I've got my object here. I'm going to make it a Christmas tree, and I am not good at drawing Christmas trees, but we will just pretend. Okay, so there's my little Christmas tree. This is my object. So this is the front of the mirror. Okay, and so if my object is a distance of 10 centimeters away in front of the mirror, my image should appear 10 centimeters for a flat mirror, should appear at the same distance away behind the mirror. So I'm going to go ahead and measure out 10 centimeters and say my image should appear around this position. Now I'm not going to measure my angles of the protractor, so it might not turn out exactly perfect, but it should be really, really close, at least close enough to give you an idea. Okay? All right, so that was step one, is just to sketch your situation. Step two is to pick any point on your object, which I like to always pick the top of it because then at least I get the height so I can see whether my object is magnified or not. I usually pick the top, but you can pick any point really and then draw a ray from that point to the mirror, like to the mirror surface, to where it is like parallel or 0 degrees to the normal. Okay, so I'm going to, and that's in green, so let's use the green marker. I'm going to draw a ray that starts here and is going to hit my mirror. Now remember, the normal means perpendicular in physics. Okay, normal is going to just come out straight perpendicular from the mirror at any point. Okay, so I just need to make sure that I hit the mirror at a 90-degree angle from this point on my object. So let's just measure that out. Okay, so I'm going to draw this incident ray here. Okay, and the way that we show here, I'm going to, incident is always, in our case, going to have solid, so this is incident. It's going to have solid arrows along it. Okay, reflected rays are going to have just little like not filled in arrows. And then when you'll see in step 4, we're going to trace the rays. Traced. You can just use dotted lines. You don't even really need arrows. Okay. Okay, so this is my incident ray, so I'm just going to draw solid arrows going towards the mirror. Okay. And then after I've drawn that incident ray, we're going to draw the reflected ray. Now because this is perpendicular to the mirror, and so therefore it's parallel to the normal, it's going to reflect back at the same angle to the normal, so it's going to reflect back at a 0-degree angle again, and so it's just going to reflect back on itself this way. Okay, so that was step 2. Let's look at step 3. Step 3 says to basically do the exact same thing as step 2, however, instead of it hitting the mirror surface at a 0-degree angle or to the normal, or 90-degree angle to the mirror, do it at some other angle to the mirror surface that is not 90 degrees. Okay, so I instead am going to okay, have it go to same point that I'm starting with, just whatever angle this is. Okay, so this is my incident ray. Okay, and if I draw the normal at this point, my normal right here goes perpendicular to the mirror. Okay, this is the normal. Okay, and this angle here is called my angle of incidence. Okay, the reflected ray that I also have to draw. So I'm going to draw the reflected ray now. It's going to bounce off of the mirror at the same angle as the angle of incidence, just the other side of the normal. So now I'm going to have my reflected ray bounce off at, try to make that the same angle I've got this one. Let's just move my paper. Roughly the same angle without using a protractor. I think this is good enough. Okay, so I'm going to draw this reflected ray here. I say that's close enough to the same angle, and I use this type of arrow to show me that that is my reflected ray. Okay. After that, we move on to step 4, where we're going to trace both reflected rays back to the point from which they appear to have originated behind the mirror. So I'm going to use dashed or dotted lines. Okay. And again, I'm going to do that for these reflected rays. I'm going to use orange. So here I'm going to go the same, kind of just extend my reflected ray, which is these arrows here, but I'm just going to extend them backwards. And you can kind of just take it as long as you need to, just in case you have no clue where your image is supposed to be. Okay, I'm going to also go back to this reflected ray here. Okay, and try to get it at the same angle. We're going to, I can't do a dotted line on this side. Okay, and this point where they intersect is supposed to be the same point on your object. There's the bell. Okay, so I can draw my object here. Okay, if you were to repeat this, you would basically, with any point, I could repeat it, and I can't draw here. Look, I was a couple millimeters off without even measuring. Okay, and you'll see in this case too for flat mirrors that your object is going to have the same distance, so this is the distance for my object, and the same distance for your image. They have the same height, your image is the same size, it's not inverted, so it's the same size, same orientation, and the same distance away as your object. It's just behind the mirror, so it is a virtual image.